welcome to part 2 of Knapsack solution. In our previous video we saw the recursive knapsack solution, and now we will use this recursive knapsack solution to build upon our dynamic problem solution. So it's simple. If you have understood the caching solution where we were caching the values for W and N, now instead of caching it in this way, we are going to use a matrix, and we will be building upon the smaller weights and smaller inputs so that we have a final solution available in the matrix. Right, so for that, let's create another function, call it as DP knapsack, and let's take all the inputs available here. Yeah, so first thing is to create a DP or a matrix that's going to solve our smaller solutions, and we are going to build upon those smaller solutions to get our solution for weight W. So matrix, so we'll use a make. So it's a matrix now, holding int, and its size will be n plus 1. And I'm also going to just go through this range of matrix, and I'm going to have k or simply k will be make of another int, and its size will be W of 1. Alright, so this is our matrix that we have created now, or we can just ignore it and use an I and say matrix of I will be this one. Now first thing is to have fill the base cases similar to our recursive solution. So that means that in case we have weight 0 and we do not have any items available, we just fill those values with 0. So we also do same thing in our matrix or whatever cache that we have created. So I'll just move it upward. So that means that for whatever value range of matrix, and for whatever cell range of V. Yeah, so if I'll use it as I comma j, if I equals to 0 or j equals to 0, then my matrix of I comma j will be 0. So for j, I'll just replace this with a W, because that's the weight, and these are indices to I is indices to weight and value of array. Right, so let's do a continue here. And now what is the next thing is to just see this at any cell DP or matrix of I comma W. Right, how we are going to calculate it. So that will be matrix, that will be value of I. Right, same thing, either I choose it. If I choose it, then I solve it for smaller value, so smaller I minus 1, and my remaining weight will be W minus W T of I, and it will be again max if I choose it or I do not choose it. So when I do not choose it, then I just simply go I minus 1 and my weight remains the same. So this happens when, again, we had the choice similar to here. I'll just copy this. This is I. Right. Else, what we do, my matrix of I comma w is nothing but if I do not select that, because now its weight is more than that, same to whatever solution we did here, right? Now this is it, this is not getting used, so our solution will be lying in our matrix because we are building this matrix in top-down fashion. So we have the smaller values being calculated, which are now we are looping through those values and the weights, and then finally when our weight is equals to w, that means that my n equals to my I equals to n and my small w equals to w. That's where my solution exists. So my solution is matrix of matrix of n comma matrix of w, capital W. Right, so let's try this solution whether our knapsack also gives. I'll just comment this out, print our DP knapsack w, same thing. I'll just copy this. Yeah, now let's run our dynamic programming solution. So we got the right result. So in case you are not sure what's happening here, go back, check video number 1, that is in the description, where we go through the recursive solution. Now we understand that how can we memorize it, and using that memorization we created a matrix in our top-down DP, and using this we are filling the values when we have a weight say ni, which is wi, which is less than w. So we are building till weight w, and by using smaller subset of values and weights. So finally, this is our knapsack dynamic programming solution in Golang. If you like this, hit like and subscribe, and for detailed description of recursive solution, go back to the video. I've shared the link in the description. Thank you.